There is a quiz posted. It's due tonight, and there's no other quiz to work on this week. It's quiz number 4. Even if you just can do a couple parts of the quiz and can't do other problems, you can just let me know that you're stuck. I can help, like give a hint, and then you can try the quiz again. So at least just give it a go. And then also you want to do homework number 7 on XYZ. It's also due tonight. Today and Thursday, we're doing notes for homework 8. Today, we're going over inequalities. Thursday are absolute values, and then also we're mixing absolute values with inequalities. Also, after turning in this homework, we take a break from homework to review the last few topics and take our second exam. Okay, so we're going to define a linear inequality. And this will be in one variable. It can be written as ax plus b, where x is the variable, and it's less than c. So some side notes. First, a is not 0. And you can switch the less than sign with greater than, less than or equal to, or greater than or equal to. Okay, we're going to talk about graphing a linear inequality. Actually, I'm gonna split it into pieces. To graph a strict inequality, so either this symbol or that symbol, like say it's strictly less than, strictly greater than. You can use open circles or parentheses. All right, if you have either of these signs, use a closed circle or a bracket. Luckily, your homework kind of helps keep things organized, but if you were drawing this by hand, either used open circles with closed circles, like that option, or use your square brackets or parentheses. So it's this choice or that choice. Don't mix them together. Okay, we also before doing examples, I have some general steps on how you want to draw the graph. So the first step. All right, before erasing, when there's no equal sign, you're going to place an open circle on your graph above the critical number, which we'll talk about. If there's an equal sign, use a closed circle. Or you can put a square bracket, but the bracket has to face the solutions. Same with parentheses. If you pick parentheses, it has to face your solution section. But in case you need to, you would start by solving for the variable. So isolate your variable. Okay, once you've gotten your variable by itself, what other numbers are included are called critical numbers. And you want to place the critical numbers on a number line. Let's start this. The next part Use those numbers to split the number line into test intervals. And we'll practice. And then from each interval, you test a point. When you test a point and you get true, you found a solution and you shade over that solution and all of the numbers around it. So you found part of your solution section. Okay, so whatever interval that test point is from, shade over it. If it's false, it's not a solution and you don't want to shade that section. So in the first example, the variable is already solved for, so we don't even need to worry about the first part. We're graphing x greater than or equal to 7. Solve for the variable. It means isolate your variable, which it is isolated over to the left side of the inequality. There's critical numbers on a number line. So if you need a number line, just one number line when there's one variable. All right, these are x values. The critical number for this problem is 7. Okay, so we use 7 to split up the number line into an interval from -infinity up to 7. And then from 7 over to infinity. And above 7, we're going to use a solid circle because there's an equal sign right here. Okay, so I'm going to test a number on this side, like test 5. Into the inequality is 5 greater than or equal to 7. That's false. Okay, if it's false, don't shade over that. It's not a solution. And this is not part of the solution section. We're going to see if the other side is test a number greater than 7. I'm going to pick 10. Any number you want, just not including 7, somewhere over towards positive infinity. putting this into the inequality is any number. Well, and I'll kind of be a little more clear. And maybe I'll back up and put it here too. Thank you for the question, by the way. So this value from the inequality breaks up the number line into an interval from negative infinity. We'll put it over here. Okay, so, and we're going to go over these kinds of sets today, but just to try to explain. The first piece we look at goes from negative infinity up to 7, and it doesn't include either end. The other one goes from 7 to infinity. And then from each of these sets, you can pick any number. Now I'm trying to see how do I explain? Well, I guess. I'm going to peek at some old notes, but then maybe just try to think through a good explanation. Hey, bud. Okay. So let me see. Right now, I'm thinking there's only 2 intervals because your number is either less than 7 or greater than 7. And then the next part is why from each of these do you need only 1 test point? Well, I mean, you can actually do like 2, 3, 4, 5, as many test points as you want. They're either all going to be true or all going to be false. So you don't have to use just 1 test point. If you wanted to feel extra confident, test a couple points and then start to sketch out the solution section where, again, you still shade over solutions, values that make your inequality true. And you don't, and if it's not a solution, you don't shade over it. All right, I think that'll make more sense as we do more examples. Trying x equal to 10 in your inequality. 10 is greater than 7, so this is going to be true. So I would shade over 10 because it is a solution. So we're going to start to like shade. And then from practice, I know I can shade that whole side, but just for the question I was asked, you could test another point. You could test 8, you could test 12. Greater than or equal to 7, also true. So we can like shade over here a little bit, and we can just start to connect all those together. So I guess the answer is you can test as many points as you like, but you really only need to pick 1 from each interval. So we're going to try one that has 3 parts. We have, let's do 0, less than x. It's less than or equal to 4. Okay, the first step we already have taken care of. The variable is isolated, so we've solved for the variable. Or it has already been solved. So next we just graph on one number line. We mark critical numbers 0 and 4. First, I'm going to check my symbols. With a strict inequality, we want an open circle above 0. And then above 4 is going to be closed. All right, so the intervals are from -infinity to 0. This is kind of a little extra explanation, but still, it's nice to be clear. Okay, this one. There's one that goes from 0 to 4, and you don't include either end. Okay, and then one that goes from 4 over to infinity. And then you want to pick test points from each interval. When they're true, you can shade over it. If it's false, don't shade over it. And we really only need one test point from each of these pieces. And it can be any point, just as long as it's like a number that's less than 0. Then we need to pick some other number between 0 and 4. And then we need to pick some number, whatever number we want, as long as it's greater than 4. Okay, let's pick a number somewhere over here, like negative something, negative. And you have to put it into your inequality. And it's a solution if it makes the statement true. So 0 less than -2 is false. So this is not a solution, and numbers over here are not solutions either. Okay, now you can pick a number between 0 and 4. It can be any number you want as long as it's in this interval. I'm going to pick 1. Putting in 1 for x. And check if it makes your statement true. 0 less than 1. Yes. Is 1 less than or equal to 4? Yes. So this is true. Which means this is a solution. And if I tested other points between 0 and 4, they would also be solutions. This would all be shaded over. And then pick a number that's greater than 4. It can be any number as long as it meets that requirement being greater than 4. Let's try 7. So again, from that last interval, I've chosen a test point and put it into your inequality. It's a solution if it makes the statement true. 0 less than 7. Well, that's true. 7 less than or equal to 4. That's false. So this is not a solution, and I don't want to shade this section. I'm going to do one more, and then we have 2 properties to talk about. Okay. Graphing x less than -5. So you first isolate the variable, which it is. X is isolated. Then mark critical numbers, like -5. And there's 2 test intervals, one from -infinity to -5. You don't have to write this down every time. I'm just trying to explain like the pieces. This first piece looks like this. And the other one goes from -5 and over. Above -5, there's an open circle. And then you test some number less than -5, like maybe -8. And then we'll pick a number greater than -5. I'm going to try 0. And then we'll see which side to shade. First test. Okay, right here is -8 less than -5. -5, this is even more negative, so it's even smaller, so this would be true. So here's a solution, which I mean, you can start with just marking that one little solution, but other test points on this side would also be solutions with shade. I'm gonna try this. It's equal to 0. Okay, for here, 0 less than -5. 0 less than a negative number would be false. So this is not a solution. Other numbers over here are also not solutions, and I don't want to shade this section. So all I need is this piece for my graph. So the first property is called an addition property for inequalities. So you start out with something like A less than B. Similar to an equal sign, an equation, we can add the same value to both sides and keep this symbol. So if we add C to this side, it's less than adding C to that side. A plus C is less than B plus. So this time we solve, which means isolate the variable. Three x plus 3. Less than 2x minus 1. Okay, so we would start our scratch work. Rewrite the problem. Then use this property first where I can. Well, I'm trying to isolate the variable x. So I want one value of x and on one side of the inequality. So I can get these numbers together by adding 1 to both sides. We still copy down the same symbol. So this is a less than. It's 3x plus 4 is less than 2x. Okay, because we haven't introduced a certain property yet, what? I'm going to back up. So there's many ways to solve a problem. I'm going to solve it a certain way just to avoid confusion. So instead, let's subtract the 3. Then I have my 3x. It's less than 2x. It's 4. Cool. Then all I need to do is subtract 2x from each side. So here is x is less than -4. And the way I started to do the problem is fine. It's just that I haven't shown the other property yet. So I would have needed to divide or multiply by a number, which we're going to go over. The multiplication property for inequalities. There's two parts. The first part is for positive numbers, and it just is kind of clear and straightforward. The second part is a trick that you have to remember for negative numbers. Part one, we have a positive number we're going to call C. C is a number that is greater than 0. C is positive. And A is less than B. So property is, if I've got a positive number, I can multiply both sides of the inequality by that number and keep the symbol the same. Again, when it's positive, you can copy down the same symbol through multiplying or dividing both sides. But if it's a negative number, you have to flip the sign. So part two. So if your number C is, or it could also be an algebraic expression, but we're going to just stick with, let's say, some value C, and it's negative, it's less than 0. And still have A less than B. But when you multiply both sides by a negative number or divide both sides by a negative number, you have to flip the sign. Okay, let's do a quick and easy one. Like solve negative 1/4. X less than 20. Actually, let's go with less than 2. Okay, so it's negative 1/4. X is less than 2. Let's say we just jump straight to isolating X by multiplying both sides by by a negative 4. Okay, so that negative with that negative makes this side positive. That 4 over that 4 is 1. And so this side is positive x. It's less, oh, actually, we've multiplied by a negative number on both sides. So I flipped the sign. X is greater than -8. Solve. -3x plus 1 less than or equal to 7. I'm just going to start working with this. So let's get these numbers together by subtracting 1 on both sides. -3x is less than or equal to 6. Divide both sides by -3. So we're going to divide by a negative number, then we need to flip the sign. Okay, so turning this around, this is a positive x, and this would be -2. Let's do another one of just solve. So we're looking at -1/2 multiplied 8x plus 10. Minus 2x less than x. So the idea is kind of like in an equation, when there's like an equal sign right here, you want to use distribution to expand all parts of the problem, then combine like terms, and then you want to isolate your variable to one side of this symbol. So we distribute the -1/2 over to 8x and 10. It's -4x minus 5. It's 2x. Less than x. I can put these like terms together. -4x and the -2x is -6x. Okay, I've got those x values together. There's also -5 on this side. This is less than x. I could add 5 to both sides. And -6x is less than. It's okay. That's plus 5. Now I want to get these x values together by subtracting an x. Here, this would be negative 7x less than. Now I would divide both sides by negative 7. Since we're dividing by a negative number, we want to flip the sign this way. And then over here is x. It's greater than negative 5/7. Okay, I want to start to talk about interval notation. Okay, intervals. Written with rectangular brackets or parentheses. Or you could call them square brackets, if this is the hard side. Okay, and then two numbers that are called the endpoints of the interval. First side note is the smallest number or smaller value always goes on the left. Okay, use rectangular brackets for included ends. So with the equal sign and a symbol. Rectangular brackets or square brackets. So I'm gonna put square. Okay, and then we use the parentheses for ends that are not included. Oh, like strict inequality, this one or this one. Okay, the last note is that negative infinity is not a number that we can include in the set, so it will have parentheses. And the same for positive infinity. So if it's a plus infinity or a negative infinity, it's going to have a parenthesis on the side. Okay, so now we can just do examples for the rest of class. We will graph the solution section and write the solution set. I'm just going to put find the solution set. I'm going to write that set in interval notation. So I think this sort of tricky one because there's going to be fractions, but if you remember from before, we can clear all fractions with the LCD. So we're looking at 4 minus 1/2 x. It's less than 2/3 x. Minus 5. So just like with an equal sign right here, if this were an equation, we would get rid of all the fractions with the LCD. So let's start looking at the LCD. You check out all of your denominators and find the most of any of the factors. So one of your factors is 2. There's only one 2. Same for 3. There's just one 3. So multiply these together and get 6. Multiply both sides of your inequality by 6. So let's start over here. Distribute the 6. 6 times 4 is 24. 6 times negative 1/2. Negative 3x. Since 6 is a positive number, I don't have to flip the sign. I just copy it how it is. And distribute 6 on this side. 6 times 2/3. The 6 over 3 will leave 2. And that 2 times that 2 is 4. 6 times negative 5 is negative. Okay, so all the fractions are gone. And you want to get the values of x together. I'm going to be adding 3x. And then I can add 30 to both sides. Yeah, I like to do it. I mean, the book and of course other teachers are totally correct in doing everything kind of long ways, but I feel like as long as we understand each other, it's okay to work down, like down the board. So I have my 24 less than 7x minus 30. Then below this, we're going to put a plus 30 on both sides. Here's 54. Less than 7x. Okay, when I divide both sides by 7, is a positive number, so you keep the sign the same. Just copy. Here's x. And just leave this as 54 over 7. So what I'm going to be going over are 3 different answers. This is an algebraic statement, and that's one of our answers. Another way to answer is to draw a graph. And I'll use those to get the solution set was actually the main part of the problem. Okay, I'm going to place 54 sevenths somewhere. I'm going to check my notes, but I think this is about 7.7. So I want to split this into an interval from negative infinity up to 54 over 7. We do not include that number in the graph, so open circle. And I'll test to point this somewhere past 54 sevenths. So I think an obvious one is some negative number. Let's try -1. And I feel like we've solved this correctly, so I'm going to use this version of the inequality. I could go back to the beginning and test the point, but we can also test it here. Is -1 greater than 54/7? Positive, let's see, a negative number greater than a positive number is false. So we're not shading this side. We want to check over on this side. Some number like, let's go with 12. Putting that right there, it's 54/7 less than 12. And that's about 7.7. That being less than 12 would be true. So this is a solution, and I can shade over here. This is a solution section. Right, last part is to write that shaded section, or write this here as a set. The set starts from the smaller number, which is this one, 54/7. Okay, you're not including that end, so it's got a parenthesis. Go over to positive infinity, and that one also always has a parenthesis on the side. I'm gonna try to do one more, and then we'll practice this next time after we kind of discuss absolute values. Ooh, this is a good one. Okay. There's 3 pieces. We're gonna do. Okay, we're gonna do this. Okay, it's -8 less than x over 3 minus 10. And that's also less than or equal to 0. Okay, so there's this piece, this piece, this piece. We want to start to solve for x by isolating it. So we can add 10 to all 3 sides. Here, in the middle, and on this end as well. So this would be 2 less than x over 3. And then less than or equal to 10. Okay. I'm trying to get this x by itself. So I can multiply by 3, but that means that's multiplied by 3 here and here too. So that's 3 times 3 times 3. This side is 6. Copy that down. It's less than x, which is less than or equal to 3. To kind of quickly sketch the graph and get the solutions written as a set. critical numbers are 6, 30. And values that make this statement true are greater than 6 this way, less than or equal to 30 that way. And then we don't include 6. We do include 30. So you can go over test points if you like, but I've kind of got a whole idea. This is what we want. Your set goes from the smaller number to the larger number, 6 over to 30. Do not include 6, but you are going to use 30 in the set. Okay, so this part up here, this is the graph. Okay. And then this part below the line, from 6 over to 30, not including 6, we are including 30. That is the set of solutions, or the solution set. Okay, and I think that's good for today. So thank you everyone who came to class. Please work on your quiz and your homework, and I'll see you on Thursday.